Hey guys, in this video we're going to be covering activity 4C.1. Our mastery learning objective is I can determine the average rate of change over a specific interval between 2 points on a graph. So the first couple of vocab is, well, what is the average rate of change? Average rate of change is just the change of the y value in relation to the x value. So the way that you'll kind of see me reference average rate of change is by using the idea of rise over run. So you'll see rise is talking about that y value, right? Y value is our rise. And then in relation to our x value, that's going to be our run. So we're going to write these average rate of changes in a fraction form. If we have a positive rate of change, all that means is that our y value is increasing. Right? So this is where basically where our parabola or our function is going up. Where is it negative? Well, this is going to be when our y value is decreasing. And this is wherever it's going to be going down. All right, so average rate of change, it's also similar to slope, right? We're trying to figure out what that rise over run is. So our slope for all of these ones is just another way of saying it. It's in context, so that's why we use the word rate of change. So looking at this first example, it says between which two coordinates is the average rate of change 3? So the first thing is looking at this. This is telling us that our answer should be 3, and 3 is positive, right? That's a positive value. So if it's positive, we need to be looking for where the graph is going up. All right, so where is the graph going up? The only place that our graph is going up is from this vertex point all the way up here, right? So basically, everything that was decreasing, all of this, we can't look at that. Ignore that side, right? We're not going to be looking at anything on this side because we need to be looking for where the graph is positive. All right, so now let's check these intervals. It says 3, 9, and 0, 0. Is the average rate of change a 3 there? So I'm going to kind of color coordinate these ones. So the point 3, 9, that's this point. And then it says and 0, 0. That's this point down here. So what you can do is you need to count the rise over the run. So starting at point 3, 9, how many down or up do I need to go to get to that 0? So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, this went down 9. Right? So I'm going to say down 9. And then how many over do I need to go? Well, 1, 2, 3. And then that's going to be to the left 3. So left 3. If I went down 9, that's going to be negative 9, right? Going down is going to be negative. Going up is a positive. Going left 3 is negative. So going left is negative, going right is positive. Negative 9 over 3 is going to be then a positive 3. That is a solution. It's an option, right? That is a positive 3. That one's good to go. So it is a rate of change of 3. Let's check some other ones. Let me change my color here. Negative 1, 1. So this is going to be rise over run again. Negative 1 over 1. And positive 1 over 1. All right, so looking at how we get there, starting at negative 1 to 1. Do I go up or down any? Nope. So that's just 0. How many to the right or left do I go? I go 1, 2. That's going to be 2 to the right. So 0 over a positive 2 is 0. Again, we're trying to figure out where the average rate of change is a 3. That average rate is a 0, so that's not going to work. Looking at the next example, 2, 4. So 2, 4 is this point. And then we're trying to go to 3, 9. So that's this point over here. So how many did we go up or down? So starting at that first point at 2, 4, how many up do I go? 1, 2, 3, 4, 5. So I go 5 up. And then how many do I go over? I go right 1. So up 5 is a positive 5, right 1 is a positive 1. Therefore, my answer is 5. That's not a positive 3, so that's not going to be a solution. Last one here, checking 0.11. So that's this point right here. And we're going to go to 2, 4. So that's this point right here. So how many up did we go? 1, 2, 3. Our rise was 3. How many did we run? 1. So right 1. Positive 3 over 1 is 3. So, what answers has this positive rate of change? Well, positive rate of change here. Positive rate of change 3 would be our first two examples, right? We have that point between 1, 1 and 2, 4. You might have more than one answer because what it looks like is that our first example as well, the one that we did in, what color was that? Green, is also an option. So sometimes you might get more than one answer. Sometimes it's only one. So in this case, we have two options. Between 3, 9 and 0, 0. Again, because what they asked us for was where does the graph has a positive rate of 3. Alright. Looking at the next example. We want to, between which two coordinates is the greatest average rate of change. So now this time it's just asking you in general. Greatest means the biggest rate of change. So we're going to have to check all of them and try to figure out where is the biggest one occurring. So starting at that first point, 5, negative 12. So 5 down, negative 12. That's at that point. And we want to go to 7, 4. So 7, negative 4. That's right here. Now remember, we are still doing our rise over run. So starting at that 5, negative 12, how many are we going up? 1, 2, but keep in mind the scale. So looking at the scale, these are going up by 4s. So if I'm at negative 12 and I'm going up to 8 and then up to 4, each of these is going to be worth 4. So the total that I'm rising is 8. All right, I'm going up 8. Now, how many over am I going? I'm going 1, 2. All right, so then I'm going to be going in the positive direction 2. Positive 8 over positive 2 is a positive 4. So do me a favor right here and just put always check the scale, right? Because these are going up by 4s. Our x-axis are going up by 1. So just always make sure you check the scale. All right, looking at the next example. We have 1, negative 4, so that's this point. So we're starting, and we're going to go to 7, 4, which is this point over here. So rise over run. Are we going up any? Nope. So that's going to be a 0. Over 1, 2, 3, 4, 5, 6. That's a positive 6 because it is going to the right. And 0 over 6 is 0. Next example here. We're going over 1, down -4, so at this point again. And we want to go to 5, 12. So at this point. Starting here, rise over run. How many up or down do we have to go? So we're going down 1, 2, but remember that my scale is going up by 4. So this is actually going down by 8, right? We're at -4, we're going down to -12. So that's going to be going down 8. And then how many over? 1, 2, 3, 4. Positive 4, because that scale is going up by 1. Therefore, our answer is going to be a -2. So going back to what they asked us was, what is the greatest? What's the biggest number? Well, the biggest number then has to be this answer right here, because this is the greatest. Greatest rate of change. Alright. Next example. So use the graph below to find, to find the rate of change on the following interval. So now this is just telling you the x values. So one of the biggest things is making sure that you write what that x-intercept is. So if it says that x equals 0, when x is 0, my y is actually 5. So that's going to be one point I look at, 0, 5. And this other point is only the x value. So at x equals 1, my y value is at 0. So if you need to write those ordered pairs for yourself, please do that, because it's going to make it a little bit easier for you to see where our ordered pairs are. And then this way you don't have to worry about messing up the x's and the y's. So starting with our rise over run. At that point right here, how many up or down I'm going to go to get to the next point? So I'm going to go down 1, 2, 3, 4, 5. So down 5, that's going to give me a -5 over 1. So a -5 divided by a positive 1 is going to give me a -5. Looking at the next set. So at x equals 0, well, we already know that that's 0, 5, right? Because that's going to be this point when x is 0. But now when x equals 2, my y value is down at a -3. So doing my rise over run, 0 going down all the way to that point. So how many are we going to have to count? Well, 1, we know that's 5, plus, so 5, 6, 7, 8. So we're going down -8. How many over? 1, 2. Positive 2. So -8 over a positive 2 is going to give me a -4. And my last example here, at x equals 3, my y value is -4. And at x equals 6, my y value is 5. So looking at these 2 points, how many am I going to go up? Well, count 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's up a positive 9 for my rise. Over 1, 2, 3. 9 over a positive 3 is going to give me a positive 3. So this one, it says, do the calculations in part B. Represent the rate of change for the entire function. So looking at part B, well, what was the rate of change for part B? That was my -4, right? So does the rate of change of -4 represent the whole entire function? Well, what does this tell us? If that blue is -4, what does that tell you about the average rate of change, right? It means that it's negative. So does that mean if it's negative, that means the whole function is decreasing? Is our function decreasing everywhere? No. right? No, because quadratics do not have a constant slope. You could have also said, well, since this was negative, that means it's going down, right? The whole function is not always decreasing because there is parts that ended up being positive because our parabola is going upward. All right, go ahead and practice these activities for C.1. Good luck.